Hello. In this tutorial, we're going to discuss how to take the linked list class that we implemented in the last tutorial and modify it so that it doesn't hold integers, but rather holds objects of a more complicated class. In this case, we're going to use the candy bar class that we had defined earlier this semester. So our goal is to take the linked list class and modify it so that it holds candy bars instead of integers. Now to begin with, what I've done is taken the tutorial code that we built last time and copied it into this new project. So we still have our main, which inserts integers. We have our list, which manages nodes of integers. And I've also brought in our candy bar class. And I'm not changing anything yet. In fact, the candy bar class is identical to what it had been before. And let's just run this and verify that the code still functions as properly. You can see that we can insert values into our linked list. We can find the position and the max, and we can delete values out of our list. So that's the function of main. It's making use of all of these things that we had done previously. Now let's go into the list class and modify this so that it doesn't hold integers anymore, but rather it holds candy bars. So the first thing to do is to come into the class node, which is the private class within the list, and indicate that we want each of these nodes to not hold integers, but rather I want to hold candy bars instead. Now I'm going to cut and paste this candy bar over a lot of different places where we saw integer before. So now the constructor of the node doesn't need to take in an integer, it needs to take in a candy bar. And that will fix the entire node for us, just replacing the data that I want to hold and the data that I'm taking in within the constructor of this class. Okay, now let's go through the list and see the things that we need to fix. You can see we've got a couple of different errors as we go through. The insert function isn't going to insert an integer anymore. We're going to insert a new node that holds a candy bar. So if I just replace integer with candy bar in the parameter that's coming into the insert function, it will fix the entire method and everything else remains the same. If I'm inserting to the end, I also need to take in a candy bar instead of an integer, and that'll fix up that function completely as well. So there's not a lot of work to do in fixing this. We just need to keep going through each one of these methods that is implemented inside of the list class, and anywhere we saw integer, we just need to replace that with candy bar. The toString function we're not going to need to modify at all because we have the toString function on the node and also the candy bar already implemented. So you can see object-oriented programming principles are paying off in that if we've defined a class elsewhere, we can simply make use of it quite nicely here as we extend our program and make it a little bit more complicated. The length function also doesn't need to be modified because it's just counting how many elements are in the list, and it doesn't really care what type of thing the list is holding. Okay, so now let's get into another method that we need to deal with. We have this max function which had gone through the entire list and found the maximum integer. And now since we're not holding integers, we need to do a little bit different work in figuring out what we want to do to determine what the maximum value is. Well, let's say that we want to search all of the candy bars in the collection and determine which one has the most calories. If that's the case, then I want to return the candy bar that has the most calories, but in my comparison, it's not just a simple greater than test anymore. I need to compare the calories of the current candy bar that I'm looking at to the calories of the candy bar that I think has the most calories in it. Notice the structure of this function is going to remain the same. We're just changing some of the details in how we're determining which one of these is the maximum candy bar. Okay, so we're going to, if the list is empty, we're still going to throw this exception, and if it's not empty, I'm going to presume that the first candy bar, or the candy bar that listhead is pointing to, is the candy bar that has the most calories. And then I'm just going to repeatedly go through candy bar by candy bar and do a comparison. Now the comparison needs to change because I want to do a comparison on the calories. So let's use our getter function, getCalories, and compare the calories of the current candy bar to the calories of the candy bar that had the maximum before. And if the current candy bar's calories is more than the maximum candy bar's calories, then I'm going to update the maximum candy bar to be this new current. So the structure is identical. No problem there, just changing candy bar to be the temporary result, and now we're going to use our getter function here and here when we're doing the comparison. And we still have an error, and this error is that I'm returning a candy bar because result is of type candy bar, but the function itself is still marked to return an integer. So instead, let's just return a candy bar. And then that fixes up this max function. Okay, so the structure remains the same. We just need to do a comparison on the calories by using this getCalories function in our comparison. I have three more functions that we need to deal with. We have the positionOf function, which takes in this thing that I'm looking for and it returns to me the index in my collection as to where it is. I have my replace function, which takes in this old value and I'm replacing it with this new value. So search on this and replace it with this for every single candy bar in the collection. And the delete function takes this thing to delete and it finds it and it gets rid of all occurrences of it from the collection. Now, no longer am I working with integers, so I need to take in a candy bar to find, and then it'll find and do the match. The problem with this is, let's say I don't want to do a comparison or a search on the candy bar itself, but rather let's look at the name of the candy bar. Let's take in a string and return the candy bar, the index to the candy bar that has that matching name. Okay, so now instead of current.data equals to find, let's use the getName getter, and I want to see do we have a match here. I need to use my equals function and say, is this the name of the candy bar that I'm currently at equal to the string that you've passed in for me? Now, if you pass in something like Snickers, the string Snickers, it's going to iterate across all of the candy bars and return to me the index or the position of that first candy bar in the list that has that matching name. Now we could have taken in the entire candy bar, and if it had an exact match, the equals function is implemented in our candy bar class, so we could have done it that way. But what I wanted to show you here was the ability to use another getter, in this case the getName, to do a comparison on and do a search, in this case on the string for the name. I want to see, do I have a match on the name? And if so, then return the index here. Okay, let's go down here into replace and modify this as well. I could take in an old candy bar and a new candy bar, but better I think would be to take in a string for each of these. So you're going to give me the old name and the new name that you want to replace, and I'm going to use a similar approach that I did here, where I'm going to use the getter on the name and say, do I have a match here? So if the list is empty, right, then there's nothing to do, but I just want to use the pattern of going through the list and looking at every single candy bar, and if the name equals this old value, then I want to change the name. So let's use our setName function on the new value. And now we have the structure remaining the same. We're going to repeat across all of the different candy bar nodes, going through node by node, and if the name matches the old value, then I'm going to change the name to be the new value. Here's another great example of using object-oriented programming principles to take something that we've already defined, in this case the candy bar class, and the getters and setters on that candy bar class, and making use of those to do something more complicated. So current.data.getName gives me the name out of the candy bar that I'm currently at. I'm going to do an equals comparison on the old value, and if I have a match, then I'm going to set the name of the current candy bar to be this new value that you passed in. And then current equals current next is just going to advance me to the next candy bar. And that'll do it for replacing or modifying this replace function. The last method that we have is this delete. And in the previous implementation of the list class, we took in this integer and we looked throughout the entire list and replaced, or deleted, I should say, deleted all of the occurrences of the integers that match this. The structure is going to remain the same here for this delete function. The difference now is that I could take in a candy bar and find a match on the delete, or like I've done in the previous two methods, we could take in a string, and if the data's getName equals this toDelete, then I'm going to delete it out of the linked list. I'm using my getName getter on the current value, and if it's equal to this thing that I'm looking to delete, then I'm going to get rid of it. I have the same structure here that if you're telling me to delete something out of an empty list, There's no reason for me to do any work, so I'm going to immediately return. Otherwise, I need to look at the first node. If you're deleting something that has a match in the first node, I need to move listhead to point to listhead next, and then that'll remove the first node out of the list. If I've dealt with the empty case and this case where I'm deleting out of the first, then the next thing to do is to iterate across the entire list collection and use this current value looking ahead and saying, is the data? Now I can't just use data because that was an integer, but I can get the name and say, are you equal to this thing that I'm supposed to delete? So you're passing me a string, and if the name of this current node's next is equal to this thing that I'm trying to delete, then make current next point to current next next and remove that node. So the work is still the same. And I'm going to go through the entire list comparing names instead of just doing a straight out integer comparison like I did in the previous implementation. And that'll do it for modifying this linked list structure. We've got the delete function just to review. We've got the delete function that takes in this string and is going to do all the work necessary to delete anything with a matching name. We modified our replace method that took in an old value and a new value now of type string, and it's going to do a comparison on the name and then update the name using our set name for these candy bars that we're managing. And we updated the position of to take in a string, and if it finds a match, then it's going to return the index of the candy bar that has that matching name. For maximum, we needed to do a comparison on the calories, and if we found the largest, then we're going to return a candy bar, not an integer anymore. Length and toString, we didn't need to modify at all. Those remain the same. And our insert and insert to end now take in candy bars, and that was the only change that we had to do there. Just as a review, the final thing that we did was modify the node to hold a candy bar instead of an integer. And that'll do it for changing this list class. Let's go here into main then and see what it's going to take to make use of this list of candy bars. Now our list class now holds candy bars instead of integers, so we're getting an error when we're doing all this insert and insert to end because it's expecting that we're inserting candy bars instead of integers, and I'm passing it the wrong thing now. So let's go through and modify this to insert candy bars into our list and see if our length and our max and our position of and our delete and our insert and insert to end all still work. Let's do that now. I'm going to save us a little bit of time and just paste in some code that I'd already had written that just makes use of the candy bar type instead of the integer type. So the overall structure of this code is identical to what we were doing with integers. We're still going to create a list of data called data, and then we're going to be able to print that out, and we're going to be able to insert and insert to end numerous candy bars of various names and weights and calorie information and so forth. I'm going to ask the list how long it is. I'm going to ask the list what's the candy bar with the maximum calories. I'm going to ask for particular positions of different candy bars, in this case by name, not passing in an integer or not passing in an entire candy bar, but passing in the string, which would be that matching name. Notice here I'm also going to look for a value that doesn't exist. I'm looking for a Three Musketeer, and in fact I never insert a Three Musketeer, so we're testing to see if that position of still is going to work if it doesn't find a match. I'm going to use my replace function by taking in Almond Joy as the old value, so anywhere where there we saw Almond Joy, it should now replace that with Mounds. I can then do a deletion on Mounds and do a deletion on Chunky just to demonstrate that it'll work to delete all occurrences of and also the first occurrence of. So let's run this and see the output that we get. Scroll up a bit and you can see that the system out println on data when there's nothing in there still works. It just prints out null. If we insert a new candy bar, we're inserting a new candy bar called Snickers. So this is the constructor of that candy bar displaying that another candy bar has been created, and here is the output when we print out the list that only contains one candy bar. Notice that the Snickers has 320 calories, weighs 2.04 ounces, and costs 75 cents with a particular ID. Is that toString of the candy bar actually working and doing what it's supposed to do? We can then print out the linked list, and you'll see that our bracket notation is still working for the particular node. So this Snickers has all this information here is the toString of the particular candy bar, but if we insert a Milky Way, you can see this is insert to end on Milky Way. Snickers is the first here, and Milky Way will be the next. And if we scroll over, you can see that as our list is growing, it actually gets quite large here, right, and scrolls off of the screen. So let's go into our list, our candy bar class, and modify the toString function just to make it a little bit easier for us. Let's not print out the cost and the weight and all of that. Let's just print out the name. So I'm going to come in here and comment out everything except just the name. So we're not changing the candy bar class, we're just changing what is displayed when we print it to the screen. And now if we run, we'll see something that's a little bit more manageable in that I've got a Snickers added, and then a Milky Way added to the end, and an Almond Joy added to the beginning, and a Zagnut added, and so forth. So you can see now that we just have the name, the linked list is a little bit easier to see here. Okay, one final modification. Let's come in here into the update ID and comment out this another candy bar has been created. So now we're not going to see all of that update information, and we're just seeing the linked list output that we want here. Again, not changing the candy bar, just changing some of the output so we can focus on the list structure now. Here in main, we insert a Snickers, and you see we have a Snickers. We insert a Milky Way to the end, and we have a Milky Way added to the end here. We then insert an Almond Joy, a Zagnut, and an Almond Joy. Here's the Almond Joy, the Zagnut, and the Almond Joy. And finally, we add the Super Snickers to the beginning of the list. So at this point, we have 1, 2, 3, 4, 5, 6 candy bars that we've added, and so the length is exactly 6 when we tell it to tell us what the length is. The candy bar with the most calories is going to be this max, and it's displaying that it's the Super Snickers, which if you look at the calorie information here, the Super Snickers has 520, which is indeed the max. If we add a Chunky with 995 calories and then print out the data, we see here's our Chunky that's been added to the beginning, and if we do a search on max again, then the Chunky is going to be the one with the most calories because it has 995. It now beats out that Super Snickers. We can look for positions information of Milky Way and Zagnut. The Milky Way's position is 6, which is 0, 1, 2, 3, 4, 5, and 6. Okay, so that works, and the position of the Zagnut is 0, 1, 2, 3. That's working as well. Remember, we start counting at 0 because that's the index that we're going to use into this. And notice what happens here in the position when we're searching on Three Musketeers. It's giving us a position of -1 because this linked list does not contain a candy bar with the name Three Musketeers. That's exactly what we would hope for. All right, let's focus on the replace method. Remember, we changed this to take in a string, or 2 strings, and this is going to be the old name, and then this is going to be the new name. So everywhere that we did see Almond Joy, we should now see Mounds. We had 2 occurrences. Here's one, and here's another. Okay, so it looks like our search and replace is working. And then if we call the delete function to delete Mounds, you'll notice that all of the Mounds are deleted out of this. If we delete Chunky, it's going to delete that first node in the list. So this shows that we can delete when there's more than one, and it's going to actually delete all of them properly. And we can also delete the first node, and it's going to delete that out properly as well. Those are 2 important cases that we had in our linked list implementation. So that'll do it for this tutorial. The takeaway that you should have gotten from this is that it's actually quite easy to go into our list definition and modify it so that it's holding, in this case, a more complicated data type, in this case the candy bar class, instead of the primitive type integer. The implementation might be slightly modified in that we need to change where we saw integer into candy bar, but the overall structure of these methods on determining the max, determining the position, replacing, doing a search and replace there, or deleting, we didn't modify any of the structure of this code. We just modified a little bit of how we were getting the names and doing a comparison and perhaps setting the names here. Right. doing a comparison on a particular property of the class rather than the whole class itself. So you should be aware that maintaining a list is the same regardless of the type of thing that you're holding, whether it's a simple type like an integer or whether it's a more complicated type like our candy bar class here. And that'll do it for this tutorial on more advanced objects being held in lists.